Within CarMaker scenarios, not only an eco vehicle can be used in a virtual world. Road users, objects to the side of traffic routes, and generally objects that can increase the natural and realistic ambience can be added to the test run. These objects are roughly divided into two groups. Firstly, there are the movable traffic objects and then the stationary traffic objects. The movable traffic objects move dynamically in the test run according to the adjustable parameters and can react with other traffic objects as well as the eco vehicle, and can also be controlled by other sources of influence such as stop markers, traffic lights, and so on. The physics behind the dynamic motion of the traffic object is realized with different motion models. In addition, traffic objects can also be controlled by specifying maneuvers. They can also be moved using a special free motion maneuver, but depends on information specified using DVA or input from file for its longitudinal and lateral motion. Finally, the biggest difference to the eco vehicle is that the steering dynamics of a traffic object motion model are not calculated. The steering dynamics of a traffic object is based on a simple approach of motion models. In contrast to dynamic traffic objects, stationary traffic objects are mainly used to create an ambience of a driving scenario and help to create a realistic visual representation. You can open a traffic menu context itself from the CarMaker main GUI by opening this via Parameters and Traffic. Or you open the scenario editor first and clicking then in the dynamic scenario mode. The main menu for the setting of your traffic objects to your requirements is to click on the button Traffic Object, and then you see on the right top a list where you can find all already added traffic objects. Let us have a look a little deeper into the structure of the settings windows of the traffic object. The first menu tab is Object Parameters. This tab is mainly used to define the overall parameters of your traffic object, like the kind and where it's placed in a scenario. You find here the subtab General, where you can define a name of the objects, and if needed you can also add a trailer. But keep in mind that only trailers that are created as traffic object and they are listed in a traffic object list can be attached. Last but not least, you can add a description to your added traffic object in a text field. The next subtab is Start Position. Here you define where the selected traffic object should be placed if the test run starts. Depending on the positioning type, you can place then the object regarding to the route or an ID of a link, and so on. In addition, the start position can be shifted parameterizing an offset or an orientation. In the routing subtab, you can roughly decide to use the routing type route, not specified, and path list. Route is used for driving along a given and selected route, and path list is the correct choice if you want to drive along one or more paths. Not specified can be used if it's a stationary object. The menu tab Movement is used to set that the traffic object should be stationary or movable. Beside the sub option, you can set the update rate of the object movement for running scenario, what is per default 200 Hz. But if the traffic object has maneuvers which involve input from file, follow trajectory, or user input, like acceleration, velocity, position, or lateral position, the update rate is set to 1000 Hz automatically. With clicking on Velocity Dependent, we can enable an update rate that depends on a traffic object's velocity. As default, here is also maneuver base selected, which enables to select a driver as driving behavior model and can also set the update rate for this driver model. With maneuver dependent, it is then possible to reference the driver update rate from the maneuver settings if activated. The last subtab inside Object Parameters is Simulation. Here we can select and deselect different options. With sensors, you can activate the detectability using specific sensors. This is more described in the user's guide. If autonomous traffic is selected, the traffic object will interact with the ego vehicle and other traffic objects, e.g. stop before it comes to a collision. Via accessibility quantities, it is possible to change the traffic object's lighting manually. The next step in a traffic context is maneuver. This area is structured similarly to the maneuver context of the ego vehicle. You find on the left the list for all maneuver steps. They are added. On the right side, you can parameterize your maneuver with general settings, like the description, but most important, also with the end condition of a maneuver step, and you can add comments that are executed during each simulation cycle for the traffic object active maneuver. In the next step, input channels, the traffic object motion can be linked to data from an external file sources using input from file. The absolute position and velocity can be given as external input. To use the external input, the data from the file needs to be mapped to a used channel. The mapping is done in the tab Input Channels. Via the tab Visualization, you can add movie NX scripts to extend the environment with e.g. options like a speedometer as overlay and other Python-based scripts. In additional parameters that cannot be set in the user interface can be set here. At least in the tab Messages, you can get a feedback of generated warnings and errors in the scenario editor. Traffic objects are created based on a traffic object template. A traffic object template contains general information on a traffic object that can be reused. Traffic object templates are created and managed with the traffic object template editor. Let me open now the template editor, and you can do this by click in the traffic menu on this button Select, then click on your chosen traffic object like this vehicle and open the editor. The first field we can see is the traffic object template list. This is a list of all traffic object templates in the project directory, in the examples and in the data pools. If the traffic object template with the same name exists in a project directory and in another place, the template in this project directory is used. Other templates with the same name are grayed out. The second menu item is the traffic object settings field. Here you can select the settings for the selected traffic object template. The menu is split in general parameters, motion model, vehicle dynamics, and additional parameters. Changes in the traffic object templates are changed in files. Change affect also the test run that used in the same traffic object template. If the settings are grayed out, the traffic object template cannot be added, e.g. because the file is stored in a location without writing access. The field 3 is filter search for current vehicle classes like car or trailer, where you can search for a traffic object template that contains a current string. In the right upper corner, you find the menu Edit buttons for create a new traffic object template, copy the selected traffic object template, remove the selected traffic object template, save changes in the selected traffic object template, and discard changes in the selected traffic object template. The last field are the action buttons, where you can interact with the traffic object template editor with save all changes, discard, or close the traffic object template editor. Let me show you how autonomous traffic will be added in a scenario and how you can parameterize it. I will demonstrate this for you with an example of a crosswalk with the traffic lights. Here the pedestrian should cross the road normally during the green phase, while the traffic waits as the vehicle at the traffic lights. However, the pedestrian should unexpectedly run back to the other side of the road, e.g. because he has forgotten something, even if the car now have the green phase. When we have finished creating everything, let's take a look at what exactly happens. First, I will open the prepare test run. I can also choose here other car as the ego vehicle. And next we open the traffic menu via parameters, traffic. Now the traffic context is opened in a dynamic mode of the scenario menu. We can see already some traffic objects included in our scenario. Some of them are movable, like the cars you see here. And some of the traffic objects, like stationary objects, of course, buildings, in this scenario are stationary. But we need to add some more to generate our wish scenario I described before. For this, I will first add a vehicle in front of us. The vehicle should stop on a traffic light and react to other traffic members as pedestrians. First, I will select my vehicle from the templates after I added a new traffic object. We can already use this traffic object if we want. We need a car. And the next step is to just add the name first. So I give this traffic object a new name. We will call it ahead. And the next step is then to adjust the position of this ahead vehicle. Since we want to place the vehicle depending on our ego vehicle, we can select reference object at the positioning type and then select the ego vehicle under object name. All the following parameters for positioning are now set in relation to the ego vehicle. We will then change the offset in the direction of the ego vehicle to 20 meters in front. And the routing should be the same as for the ego vehicle, so we can observe easily the behavior of this traffic object. For this, we click on Use of Reference Object. This is already done here. In the next two fields, we can use the presets because we want to use the head vehicle as a movable object, and we want also that this traffic object should interact with other scenario objects. So this is already set. With sensors, this traffic object can be detected by other vehicle sensors, and with the option Autonomous Traffic, the traffic object behaves like it would be used an object sensor and will interact with objects in front depending on the distance and velocity. Besides, I will also open the MovieNX. We later can see what's happened. After we set our start values, we have to define a maneuver that this traffic object car will drive in front of us. Because we will trigger interactions later via the autonomous mode automatically, we need only a start configuration and one maneuver for straight road. For this, first we go in the maneuver settings and we set a start velocity of 80 km per hour. As our ego vehicle have the same start settings. We can also change the action at the end to freeze position, what is here already set as default, so that the traffic object normally would disappear after all maneuvers are done. As next step, we had to add a maneuver step. We set the limit of time to 300. So we have enough time to execute the scenario, and we set the longitudinal and lateral dynamics to autonomous driving. This will cause that the traffic driver is used. This behaves like the IPG driver. And we set the speed here to 100 km per hour. So the driver tries to reach, but depending on the environment, e.g. speed markers, etc. The settings are enough to use this vehicle for our use case. As next step, we had to add a pedestrian for the target scenario. We add first a new traffic object, and we can select via the traffic object template menu and pedestrian from the peoples list. I choose here pedestrian male casual IPG. The next parameters are quite similar to parameterize as the traffic vehicle before. We adjust the name. Here I give a short name like Pat. Choose and route. Here's route 0 correctly set it already. And we want to place the pedestrian. We set an offset of 351 meters from the start point. And in S direction, this is then the X coordinate for the system of the route, because there's the crosswalk, and we set the lateral position to minus 2.5 meters beside the street. So the pedestrian stays on the footwork at the beginning of the scenario. Like here. We set the movement mode to movable, what's already as default set it, and activate the options for autonomous driving also, what is already checked. The more important part is to set the maneuvers for the pedestrian. Normally all traffic objects moving along the referenced position like lane, route or path. Here we want to move the pedestrian only along a lateral position. As first we go into the maneuver settings and set the start condition. We use here a trigger value from the traffic light, this then called like this. And we let the start velocity at 0. After the end of all maneuvers, the pedestrian should stay at his end position. For this, we used also the action at end mode freeze position, what is here set as default. To achieve the situation that the pedestrian crosses the road but then goes straight back again, we need 2 maneuver steps. The first one, we set the time to the maneuver to 10 seconds and only set the lateral dynamics with motion to an offset of 8 meters. In the second maneuver, we add here, we set the time to 11 seconds and we set the offset of the pedestrian to -8 meters for walking back in the same way like before. Now we have all we needed for the traffic objects for our scenario. Let's see how it's look like. The vehicle in front of our ego vehicle now drives to the traffic lights. As the traffic lights turns red, it stops and our pedestrian crosses the road. When then the traffic light changes back for the cars and we can drive away, the pedestrian crosses the road again. Now there would be a collision. However, thanks to the autonomous traffic mode, the vehicle in front brakes and the collision is prevented. Other traffic objects also react to the situation, e.g. the vehicle behind us. I will show you. Here we're driving to the traffic light, it's already red. The vehicle behind us also stops. After it's got green, all cars driving away. But after the next stop, we also see the Porsche behind us is also braking again. The smart traffic generator, as option beside the normal traffic menu, was developed as a fast and easy way to simulate the ego vehicle in a fully automatically created scenario. Traffic objects are continuously created and on new sections of the road during the simulation, while objects that have passed the ego vehicle disappear. The generated traffic objects come with both longitudinal and lateral autonomous driving maneuvers. To parameterize the generator, all options are organized in 4 menu items. The first one are the general parameters. In this tab, general parameters for the created traffic objects are defined. In the field Smart Traffic, 3 different modes are defined. These modes can be used in parallel. But when using these modes in parallel, keep in mind that problems interactions between the created traffic objects can occur. Within the sub-menu tab General Parameters, you can activate a plausibility check via Coordinate Smart Traffic Behavior. Between using the Smart Traffic Generator mode Traffic Swarm and user sources in parallel. With Offset of Range, you can change the center of the covering field where traffic should be generated around the vehicle. And with the option Velocity Depend Range, traffic objects are displayed in IPG Movie and MovieNext and are detectable by sensors within the range. The range is correlated linear to the ego vehicle's velocity. In the last tab option Expert Parameters, you can set the max number of visible traffic objects and the number of available traffic objects. The latency between positioning a traffic object in a scenario and to visualize it. At least also how many tasks should be outsourced in a separate thread. The wait time for the simulation is paused if the separated thread is not finished. The synchronization period after which the road section is updated with the results of the separated, and the synchronization period after which the generation object in the source is updated with the result of the separated thread. When using the traffic swarm mode, only a defined area around the ego vehicle, the outer link range, is considered for automatically generated traffic objects. When the ego vehicle moves along the route, the outer link rate is adjusted automatically. The area's boundaries are limited by automatically set sources and sinks. Traffic objects are created within the outer link range or in sources. This mode saves performance because traffic objects that are out of the sight of the ego vehicle are not simulated and do not influence the ego vehicle sensors. At general parameters, you can mainly adapt the ratio between traffic object types and the density. In the field expert parameters, you can decide between preview mode, how to calculate the outer link range, and other options depending to this. User sources. As next step, create autonomously driving traffic objects on lane paths at the defined position on the link. A generated traffic object starts driving when a certain condition is met, like density or weight speed. Here in general parameters, traffic objects are defined that are generated by user sources, are only visualized within the ego vehicle covering range. In source, the sources will be defined of the traffic object that are generated automatically. To add the source, click on the plus button next to the source list, and then, for example, to a link in your scenario. And to remove the source, select the same source here, and you can deselect it or delete it with the minus button. Via parameters, there are many options available to adjust the behavior of the generated objects, like how fast they can be or how the density should be in a range between 0% to 100%. The user sync menu is then set up and structured in the same way as the user sources, but only in the context of the sinks. For simulations with a large number of traffic objects with no specific maneuvers, random autonomous driving traffic object can be generated in a scenario data based on stochastic calculations. This method is far simple and requires only minimum input to generate function traffic objects. The generated traffic objects are added to the traffic object list. The generated traffic objects then have only default values, and these objects can be used as basis for larger traffic simulations. All parameters that are available in the traffic objects definition can be then adapted. To generate traffic objects, at least one route and one road are needed. In the tab Assisted Traffic Generator, you find Link List. This is a list of all links on which the traffic objects are placed. To add a link, click the button next to the link list and select a link by clicking on the road network. Click and hold the button for more options. To remove a link, select a link and click the button next to the link list. Click and hold the button here also for more options, like remove all links. With positioning, you can decide should the traffic object generated on a selected link moves on a route path or on defined lanes. With start offset and end offset, you can adjust the offset of the traffic objects. In the tab Available Routes, starting lanes, you can show all given routes and lanes. They are placed already in a scenario. You can then click on the routes or lanes where you want to generate the traffic on it. With the parameters, traffic density and car ratio, you can adjust how many traffic objects should be placed depending on the size of the street in person and how the mix should be between normal cars, trucks, and smaller traffic members like pedestrians. The last menu item, Driver and Traffic Object Template Selection, lists the rate is shown. Rate's default values range from 0 to 1. Rate defines the relative amount of times this object is included in the generated traffic compared to other objects. Near to 0 means that this object appears less often than other ones. If no driver for the traffic object generated with the traffic generator is defined, the default traffic behavior is used. With the option Adapt Vehicle Start Velocity, you can ensure that the traffic object does not start with a velocity that are unsuitable for the generated traffic situation. Nevertheless, with Delete All Existing Traffic Objects, you have the option to delete all already existing traffic objects when generating new traffic objects. This was all about the topic traffic in CarMaker, and we hope you will have a look in our other online tutorials.